Collaboration, collaboration, collaboration. That's what DevOps is all about. So in this video, we're taking a look at configuring a Git server. This can be done in many ways, through the file system, through SSH, through HTTP, but you can also do it using the Git protocol. Using the Git protocol, we're working on port 9418. It doesn't support authentication, so it's good for public read-only repository or internal repositories that are only accessible by your own department. Here we are then, working at the command line of my Rocky 8.10 system, and in fact I've got two Rocky systems set up. One can act as a server, this one, Rocky 1, and the other will act as a Git client to prove that we can clone the repository remotely. So the first thing is to make sure then that we've got the required software installed. Now I will have Git installed on this system, but just to show that obviously we're going to need Git installed, but also the Git daemon package. So we can go ahead and install these and it will come down relatively quickly. Now let's go forward and create ourselves a user account. Typically I would use the user account Git. So I can go through and use user add. We'll create the home directory, but that home directory I'm going to make sure is in SRV and Git. And let's see if we can spell SRV with an S. It might help it just a little bit. So this will be the root of all my repositories. And I'm going to call the user Git. Now, we don't need to log in as the user Git, so we're not setting a password, but I will go through and get an interactive shell. So using sudo -u git -i then gives me an interactive shell as the root user. Obviously, it's dependent on my sudo abilities, but yeah, this is going to allow me then in as the user Git. And from here, I can go ahead and check that I am in SRV Git, so the home directory that we set, and I'm going to create myself a new and empty repository. So using git and init --bear, and we'll specify the directory example.git, and my fingers really aren't working, so let's make sure we spell example with an X, and there we go, we've now created that. Now, of course, I can list the repository, so when I go through and do an ls-l, we can see then the example.git, so my empty and bare repository. And there you go, that is all we need to do as our Git user. So we can then exit out of the sudo shell, and we're now going to create ourselves a systemd service unit for our Git daemon. I'm going to go through and use systemctl and edit, --full, so we're creating the complete file, --force because it will complain because it's not there, and then I'm just going to call it git-server. There is an existing service unit and socket unit, but I'd have to do too many changes to that, so I like to create my own. As we look, we've got our standard unit entry with a description and specifying when it needs to start. Our service section is the important bit. The exec start here is running git with the subcommand daemon. --enable equals receive pack. We only need to do that if we want this to be a read-write repository. If we don't have the --enable equals receive pack, then people can read from the repository but not write back to it. So just be careful about that. This is what we want to enable if we are in a collaborative internal network. The reuse address is if it needs to restart. It doesn't need to worry about closing connections. The base path is pointing through to the home directory, and you can see we've got the export all. The idea of that is so we don't need to worry about exporting each of our repositories out. So let's go save our changes, and then we can go through and run our systemctl and daemon reload just to make sure systemd knows about this new file. And then we can go ahead and use systemctl, enable, and start our service now. And then git-server. So we should be up and running now. So if I look at my open ports for TCP, we can see port 9418 open. And if I go through and take a look at it without the -n, we can see that's recognized as the Git protocol. With that in place, we can go through and set up a firewall rule. Remember, I want to access this from my second Rocky system. So we can go through and do an add service equals Git. Now this is then in memory firewall. We can make sure then that it is flushed to our permanent configuration by running the runtime to permanent. And with this done, I can return back to my host system and then connect into my Rocky 2 system. And we're going to be able to prove all of this is working now with the Git clone. And we're using the Git protocol going through to my Rocky 1 system, which is 172.16.247.160, and then example.git. Remember, we set our base path to be the home directory, so we're looking in the user's home directory. We've obviously cloned an empty repository, which is what was set up, but then we can show that it is working in our write environment as well. So if I go through and do a touch of readme.md, we can add this. But of course, before we clone it, I haven't used this system before. We have to add in our user email and our username. So we can use then git config. And we can set our global configuration. And we can set then our username. And then we can go through and set this up. Okay, looks like I've written an email. Well, we've got to change one of them. Let's go back and change username to be user email. And with that sorted out, we can try and see if we can get the next one set. So if we've set the email already, we can then go through and set our user name. And we can set this maybe to Tux Penguin. So let's go through and configure this. Having configured our identity, we're going to be able to run our commit. Obviously, to do a commit, we have to know who the author is. All of this is still local, but we can now go through and do a git push, and it's proving that we have write access through to our Git repository. Remember, though, this is unauthenticated. It's nothing to do with our Git username or email. It's just that we've made this public readable and writable. If we don't want it to be writable, we could then go through and remove the option from our service unit where we put -- enable receive pack. That's making the Git repository publicly writable. If the requirement is read-only access, then that's relatively simple to configure. We can go through and look at working back on my Rocky 1 system. And from here, if I go back into the service unit, it's the service unit where we go through and execute the git daemon command. So we can go back and edit our service unit. And looking at the exec start line, what's giving us read and write access is the enable receive pack. So all we need to do is just remove that. It's a simple matter. Once we've done that, go and save our changes. Make sure that systemd knows about those changes, so we can go through and use Control and R, getting back to my reload command, and then we can restart our Git server service unit. Now, if we return back to my Rocky 2 system, we're going to be able to test this. So I can go back to Rocky 2, and if I move into my example local repository, and from here, let's go through and create ourselves a brand new file, and then we can go through and run our git add and our git commit. Obviously, there's no need now to go through and set up our email and username. And once we have our commit message in place, let's try now and run our git push. and we should fail on this because we only have read access. Now, we probably need to test that we do have read access. All we've done is prove that we can't write, but we can still read. So if I go and remove the example directory, remember this is just my local copy, and then check that we can clone it. Again, I can just go through and use Control and R, searching for clone, hitting the Enter key, and you can see that we've been able to clone our repository. It's obviously not showing as empty now because we had previously added in our readme.md file. The next option we're going to take a look at is selectively exporting our repositories rather than exporting them all. So again, we're working on our Git server Rocky1 and we're editing our service unit file. We've already removed the option Enable Receive Pack to make the system read only, but obviously we have this option here --export -all, and if we remove that, well, would you believe then we're not exporting our repositories automatically. We have to manually export them. So if I now go through and reload systemd and restart my Git server, we can check that we no longer have access to this by returning through to my Rocky 2 system. And let's make sure that we delete the current copy of the repository, our cloned copy. So the example subdirectory. Now, of course, that's just my local copy. But now when I try and clone it from the server, you can see that we don't have access or the repository is not exported. So we don't have access at the moment. Now, of course, to give access, we've got to jump back onto my Rocky server. But it's a matter of just working within the file system. I don't need to worry about working within the service unit now. Safely back working on our Rocky1, the Git server, we can use sudo -u to switch to our Git user account. And from here, we can then go through and create a new file. It only needs to be an empty file. So I'm touching /srv/git /example.git. And we need to create the file git-daemon-export-OK. Make sure that you've spelled that OK. And if you're happy with it, hit the big Enter key. And then we're ready to continue. We've now exported this repository and we can return to Rocky 2. And now when we try and clone our directory, you can see that we're cloning it. It's still only read only, but we can see now that we can selectively export the repositories, only exporting the repositories that we need.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.